I'm going to go over the Bohr model of the hydrogen atom and the electromagnetic spectrum with you today. This is on your reference table. Reference table is something that is given to you on your chemistry exam, so you'll be able to use this very same thing on your chemistry exam when you take it. So the first thing down here is electromagnetic spectrum. So this is showing electromagnetic waves and how they are in relation to each other. So you have radio waves, microwaves, infrared. You have visible light here. So these are the colors of visible light, avoid UV. Then you've got ultraviolet, X-rays, and gamma rays. So these over here, it says shorter wavelength. They're going to be closer together. So that means they've got a short wavelength and they have a high frequency. So these are your strong waves. These are the ones that do the most damage. UV, we know, can give you skin cancer. We have the ozone that filters out UV rays. X-rays we use in the medical profession, but you're not supposed to get a bunch of X-rays because it will end up hurting your body. That's also when they put the lead apron over you, like when you get a dental X-ray, is so you don't get exposed to the X-rays in your other organs. Gamma rays are released in a nuclear bomb or a nuclear reaction, so they're really strong waves that come out of that reaction, and they do a lot of damage. Visible light kind of separates the weaker waves from the stronger waves. So that means that the violet light is the strongest of the visible lights because it's over here by the stronger waves. So over here we have the ones that say they have a longer wavelength. Wavelength is just peak to peak. So these are going to be low frequency waves. And you've probably heard that when you heard people talking about radio waves being low frequency waves. And they're also weaker. So these have a long wavelength, a low frequency, and they're weaker. These have a high frequency, a short wavelength, and they're stronger waves. Then you've got your visible light. So it goes from roughly 700 nanometers to 400 nanometers. That's just the wavelength. So you can tell that this one has a longer wavelength. This is 700 nanometers. This one has 400 nanometers, so it's a shorter wavelength. So it's a stronger wave than like the red. If we look at the Bohr model of the hydrogen atom, basically this is showing an emission spectrum. So what it's showing you have something called a ground state and an excited state. So ground is just like it is. That's where it is normally. That's like where its feet are placed on the ground. Excited is like it says. It gets excited and it jumps. So it'll jump up in energy level, and when it falls back down, it will emit a wave. Now, some of this can be visible light that you can see. Others, like UV and infrared, are not. So the way that you read this, the question will be like, what kind of wave is emitted if you go from n equals 6 to n equals 2? So we're going to find n equals 6, that's this outside line. And we're looking for where it goes to n equals 2, that's this line, so where it's pointing to. So n equals 6 to n equals 2, and then we're going to follow it down, and that gives us visible light. And that would be at 410 nanometers. We know it's by UV, so more than likely that's going to be like a purple color, a purple or a blue color light. If it gives you n equals 5 to n equals 3. So we're here. This is n equals 5. Okay, so we're going to follow that line around. See when it goes to n equals 3, This is N equals 3 line. So then we're going to follow it down, and it gives us infrared light. IR is just infrared. And it was at the 1,282 nanometers. So these are really easy. It tells you which one it's going to start at. So it tells you like N equals 4. Okay, and it'll say N equals 4 to N equals 1. You follow that line down, and it'll tell you what kind of light that it's in. So your questions may ask you what kind of light, what color of light, but all you do is you just follow the little dots from where it says it's going, and then you follow it down, and it will tell you what area that it's in. So you're going from ground state would be where it's falling back down to. This would be its excited state. So it was here, it jumped, it fell back down, and when it fell back down, it emitted whatever is here, this frequency.